All right, so today I'm going to review with you how to name compounds again. So we talked about two different types of bonding, ionic and covalent, and how we name them differently. So first off, we need to be able to identify, do we have an ionic compound or a covalent compound? If you recall, an ionic compound, we have the transfer of electrons. When electrons are transferred, that means one element gives one away, one gains one. In this case, metals give them away. So if a metal loses an electron, it becomes positive. And then the nonmetal gains the electron and becomes negative. And so because of that, we have to use the charges to determine the number of atoms. And again, this is between a metal and nonmetal. Okay. The other thing about the charges is that they must add to 0 because compounds are neutral. Okay. Now, we also have where we have to use Roman numerals sometimes because some metals have more than one possible charge. When that happens, we have to use these Roman numerals to tell the charge, right? So it tells the charge of a metal. Okay, now, not all metals need this. Okay, there we go. Not all metals need the Roman numeral. So the exceptions are group 1A, 2A, and 3A. And then zinc and silver. Okay, these do not get any Roman numerals. And the reason they don't get a Roman numeral is because the elements, the metals in groups 1A are always +1, group 2A are always +2, and 3A are always +3. And zinc is always a +2, and silver is always a +1. And so since their charges never change, right, they get no Roman numerals. Okay? So that's ionic. The other was covalent. And so for our covalent compounds, remember these are between nonmetals only, and this is the sharing of electrons. Okay, and these are between nonmetals only. Okay, and we use prefixes to tell the number of atoms. Okay. Now, in covalent, as in also sometimes ionic, the second element name ends in IDE. Okay. Now, ionic, some of those do if it's what we call binary, and binary means 2. So if there's only 2 types of elements, then the second element for ionic also ends in IDE. But if there's more than 2, that's when we know we have a polyatomic ion. Remember, your polyatomic ions are in your reference packet. Okay? So let's look at some examples and do some practice together. All right. So first example, again, we want to first determine, is it ionic or is it covalent? Okay. All right, let's start with these. So when you are doing your practice later, you're going to want to first come up with a system. I say to do two things. First is determine, is it ionic or is it covalent, right? And so you can just put an I or C, and some worksheets that you have, it tells you to do just that, right? So here we have iron and oxygen. Since we have a metal and a non-metal, that makes it ionic. So I'm going to put an I next to it. And then here we have carbon and oxygen. That makes it covalent because they're both non-metals. So I'll put a C next to that one. Then we have potassium and phosphorus and oxygen. So we have a metal and some non-metals. So again, that makes this ionic. All right, so now let's determine the names, right? So since this is ionic, number one, right, sometimes we have to use a Roman numeral. And we just reviewed that we have to use Roman numerals to tell the charge of the metals unless it's in group 1, 2, 3A, right? Or zinc or silver. Well, iron is not in groups 1A, 2A, or 3A, so we're going to need a Roman numeral. And so what I sometimes do, I might put like a little star next to it to remind me that I need that Roman numeral. Okay. In this compound, this ionic compound number 3, we have potassium, which is in group number 1, so it would not need a Roman numeral. Okay, so that's a way to kind of organize your rules. Okay, so next let's just do the ionic ones first. So since we have iron, we name iron. We started to say it needs a Roman numeral, so we'll put the parentheses in there. And then we say O, right? Not oxygen, but now oxide. And again, it ends in IDE, right? Because there's only 2 elements, binary. Now we need to figure out what is the charge for iron, because that's the number that goes here. So we look up the charge for oxygen. Oxygen is in group 6A, which means in order to fill its octet, right, it would have to gain 2 electrons, right, because it has 6 valence electrons. It would need 2 more to get an octet. So if it's gaining 2 more, it's going to be a -2 charge, right? And then we need iron to be make -2, equal to 0. So what charge of iron would make -2 equal 0, right? +2. And so that is what we put into here, only we use a Roman numeral, not a standard number, 2. Again, that's the charge of the metal. All right, next, number 2, we said was covalent, right? And covalent, we use prefixes, right? Except we don't use the mono prefix on the first one, so this would be carbon. And there's 2 oxygens, so it would be di, and then oxide. All right. And finally, the third example, we have potassium, just K. Again, no Roman numeral, so we just write potassium. Then we have PO4. Since we have more than 2 elements, we know this is a polyatomic ion. So we look in our reference packets, we find our polyatomic ion list, and we see that PO4 is called phosphate. Okay, and that's what we write for the name, just potassium phosphate. All right, so let's look at a couple more, and then we'll go the opposite direction. All right. All right, so first let's identify, is it ionic or is it covalent? So number 4, calcium and nitrate. Since calcium is a metal and nitrogen and oxygen are nonmetals, this is ionic. And number 5, phosphorus and oxygen are both nonmetals, so that's covalent. Number 6, nickel is a metal, and sulfur and oxygen are both nonmetals, so this is ionic. Now, with ionic, we also have to determine, do we need to use a Roman numeral? So calcium, we find that it is in group 2, so that means it needs no Roman numeral because it will always be a +2. We look and we find nickel. Nickel is not in group 1A, 2A, or 3A, and it's not zinc or silver. So we're going to need a Roman numeral. So I'm going to put a little star next to that to remind me to do that. All right, so now let's name them. Number 4, we start with the metal, is calcium. Right? And then our anion, or our negative ion, right, NO3, since it has more than one atom, it's a polyatomic ion. And so we look it up on our polyatomic ion list in our reference packet, and we find that it is called nitrate. So this is calcium nitrate. Right, and then number 5, we have phosphorus and oxygen. And this time we have 3 phosphorus. So the prefix for 3 is tri. So we try phosphorus. Then we have 7 oxygens, and 7 is hepta, and that would be heptoxide, because remember, we drop out the A, so it's not heptaoxide, but heptoxide. Again, you're going to want to keep reviewing your prefixes so you don't forget those. All right, and then number 6. Again, it's ionic. We start it, which means we need to figure out what the charge for nickel is. And so I know it's going to be nickel something, right? And then we look up our polyatomic ion list. Again, we have more than one atom here, so we know it's a polyatomic ion. SO4 we find is called sulfate. Again, those are in your reference packet. Now we got to figure out what is the charge of nickel. To do that, we need to know what is the charge of sulfate. Well, sulfate, according to our reference packet, is a -2. Since we have 3 of those, we will multiply by 3. Right? And we need these charges to add up to 0. So when I add those to what nickel is, which I have 2 of those, right? So some number times 2 plus -2 times 3 has to equal 0. Well, -2 times 3 is 6. So what number plus -6 would equal 0? Right, a +6. But now we got to say what number times 2 gives us +6. Exactly, 3. And so this is nickel 3 sulfate. Okay. All right, let's try to go in the other direction, where I give you the name and you write the formula. All right, let's try vanadium 4 sulfide. Aluminum nitrate. And then diboron pentoxide. All right. So again, we need to identify, is it ionic or is it covalent, right? Vanadium is a metal, it's on the left-hand side. Sulfide is a nonmetal, so that makes this ionic. Aluminum is a metal. Nitrate has nitrogen in it, which is a nonmetal, so again, that's ionic. And then boron and oxygen, right, are nonmetals, so that makes them covalent. Now, we also know this is ionic because it's got a Roman numeral in it. We also know this is ionic because there's no prefixes, right? And our covalent are the only ones that use prefixes. That's another way you can know when you see the name. All right, so vanadium 4. This 4 means that vanadium is +4. Okay. We look up on our periodic table, sulfur is in group 6, and again needs to add 2 more electrons to get to an octet, so it makes it a -2, so it adds 2 more electrons, that's -2. Now again, these charges, they have to add up to 0, right? So a +4 and -2 becomes 0 if I multiply the -2 by 2, right? So that means I get 1 vanadium, right? And then 2 sulfides. So that's Vs2. Okay. Then we get aluminum and nitrate. Again, we look up the charge for aluminum. They didn't give us a Roman numeral, so we have to find it in the periodic table. We find the aluminum's on group 3, so that makes it a +3. Right? We look up nitrate because it ends in 8, or if it ends in ite, it's going to end up being on your polyatomic ion list. So we find that. We find nitrate, and we discover that that is -1. Now, do those equal 0? No. So how do I make them equal to 0, right? When I add them together, right? So I'm going to need 1 aluminum and 3 nitrates. So I get 1 aluminum, and the nitrate is NO3, but that is only 1 nitrate. To have 3, I have to put parentheses and then a 3. Right? And then the next one, diboron pentoxide. Di means 2, so that means there are 2 borons. Pent means 5, so that's O5. Okay? Let's do a couple more. All right, so next. First, let's identify if they're covalent or ionic. So here we have phosphorus and oxygen. They're both nonmetals. That makes them covalent. Then we have zinc and carbon, right? Zinc's a metal, carbon's a nonmetal, so that makes it ionic. And then we have strontium phosphate. Strontium's a metal. Phosphate, if you look again, ends in 8, so that's a polyatomic ion. Look that up on our reference tables. We'll find that's made of phosphorus and oxygen, and so that's ionic. All right. So next, for covalent, we use our prefixes. So we have 4 P's. P's phosphorus. 4 is tetra. So we get tetra, phosphorus, and then 9 is nana, but we drop the A, and so we get non-oxide. Okay. All right, 11, zinc carbide. Now, it's ionic. They didn't tell us the charge with Roman numerals. That must mean we have to know it. Remember, zinc, we have to remember, is always a +2. You just have to learn that one. And then carbon, we find it, it's in group 4, which means it has to gain 4 electrons to get to 8, so it's going to be a -4. Now, did 2 and -4 equal to 0? No, but how can I make them equal to 0? I can do that if I multiply zinc by 2, so that will give me +4. That means I need 2 zincs and 1 carbon. So that would be zinc carbide. Right, next we have strontium and phosphate. Right, so we look up the charge for strontium. We find that strontium is in group 2, so it's +2. Phosphate, we look up on the polyatomic ion list. Again, it ends in 8, and that's got phosphorus and oxygen in it, and then it has a charge of -3. Now, do those add up to 0? No, but how can we make them add to 0, right? Think of lowest common multiple, right? It would be a 6. So I multiply this by 3 and this by 2, and I'll get SR3 PO4 is phosphate, so to get more than one, you put parentheses and then a 2. Okay? All right, and that concludes our review of naming and writing formulas for ionic and covalent compounds.